Hello everyone, today I'm going to talk about the 20 number challenge, win rate of it, code of the game and the script I made to test it. So, this here is the game. We have a state here. This tells us whether we are playing or won the game or lost the game. This here is the score we have. This is the current number the game has gave. So, in this game, we have 20 places. The random number generator gives us a number between 1 and 1000, and we place it into one of these places. So, for example, it gave us 70. I think that's a pretty low number. I place it to 2. It gave us 272. I place it to 5, 292. I placed 6, 7, 961, 19, 125, 3, 900, 18, 521, 10, 570, 933. As you can see, 933 is bigger than 900 and lower than 961. So I need to place it to somewhere between 18 and 19. But I can't, because there is no place there. I can't overwrite these also. So I'm gonna place it somewhere else. And as you can see, I lost the game. This is how the game's played. I can't show you a state where I win the game, because that is very unlikely in this game. So I will just continue. So to calculate how the win rate would be if you were playing the game really great, I did what I do best, coded the game in C#, made my software play it very good, and make my computer play it 10 million times. I recorded the results, but since the results were 15 gigabytes, I couldn't open it with Notepad, so here is another software. By the way, I have recorded all of the rounds. As you can see, we have the first number in the first game given was 997. Our software placed it at 20. The second number we got was 210, which our software placed at 5, and so on. The game is played 10 million times, so there are a lot of rounds that are recorded. So if we check the end of the file, like this, as you can see, we have won 140 times and lost 9,999,861 times. So if we calculate from here, we have played, we have won 140 times and we have played 10 million and 1 times, which is equal to 0.5 zeros and 1.4. Or, if I may show you in a more regular sense, as you can see, 0.0014%. So it's pretty much impossible to win this game. when you play, even when you play it, right? And let me now continue with the codes I wrote. So for the game, I have a body, background color, all that stuff. We have a paragraph with ID game state, has playing in it, and has a yellow color defined by a span. We also have a score paragraph with written score 0. We have a current number paragraph with current number written like this. It has an empty input, and actually it doesn't matter if it's written like this. As you can see, since we are calling this function at the start of the game or at the start of the website, let me show you. Yeah, here we call RNG function, which changes the inner HTML. Wait. Here. Changes the inner HTML of current number ID'd paragraph, which is this. It doesn't matter what is written here, but I will leave it like this to make it more readable. I didn't use a separate file for JavaScript or CSS because the only time I used CSS was for this, and the only time I used JavaScript was for this. This is not very little or pretty way to do this, but yeah. I store the last changed number ID in order to make this. Let me show you. In order to make this last one red, I save the last changed number ID, which is 8 in this instance, and I decide what is going to be red according to that. Then I have a numbers array which stores the numbers that are in these separately. I have a score variable, state variable. State is either true or false, it's a boolean. And if it is false, the game is at halt. You can't play the game, which is only happens when you lose or win. Which I wasn't able to check for win, by the way, because, you know, it's pretty much impossible. And what else? Okay, let's go through the functions one by one. The RNG function checks if state is true, because if not, it's not gonna do anything. Like I said, game is at halt. It creates a random value, multiplies it by 999, because if you don't know, the math.random gives out a number between 0 and 1. And since we want between 0 and 999 here, I multiply it by 999 and give it a +1 so that it is between 1 and 1000. Then change the inner HTML to current number is X. So in select order, this is triggered by these buttons. These buttons call that function, as you can see. If you click the button next to the order 1, it calls the select order and gives inside a 1. Rest is the same, 1, 2, 3, 4, 5, up to 20. if the inner HTML is equals to this, which means it's empty and is not selected yet, we change the last change number ID, because now it is wherever we just clicked. We change the number and change what's written in it. We also check number order and create a new number. You know what creating a new number also RNG does. So when I click this, it creates a new number, as you can see. And our X is now 965, as you can see. So check number order that goes through all of the numbers and checks if they are in order. If they are not, it writes game has ended in red and makes the last changed number red, so you know which placement was wrong. It also updates the score. If the score is bigger than or equal to 20, which will never be bigger than 20 by the way, if the score is equal to 20, you will have a game has won written in green, and it also triggers RNG, of course, so the next number will appear. Oh, sorry, this is when the script is HTML page is first loaded. This is not in parentheses. So yeah, this is a table. It's obvious. Yeah, this is the game. Now I will show the code I run to make my computer play this game 10 million times. So in C#.NET 6, as you know, these are in main and these are separate functions. I separated them with this to make it obvious. Also, some of these are not in main but in the script itself, in the class, you know. So let's get to the while function, while loop here, which is in the main, by the way. So we create a number between 1 and 1000. This is exclusive, not inclusive. We call write to console function and write the number. Write to console function, by the way, has a console.writeLine and writer.writeLine. This one is for saving to the file, the 15 gigabytes of txt file I have showed you before. We have a place f, which means the number we are going to place, which was named x in the HTML file. It is calculated like this. We double the number, divide it by 100 and make it go up. If it is 20, we make it go down a bit, because if it is 1000, if we land on 1000 here from the random number generator, it goes up to 20, which will throw an overflow, because we have 20 numbers and in C# arrays start from 0, so the 20th will be actually 90. And we place the number, we check the board if the game is won or lost or something like that. and we continue. Actually, I just realized we don't need to check the board because this place function here does everything for us. It decides if we won, if it decides if we lost. Well, actually it doesn't decide if we won, but all of the lose things are calculated here. So this is a recurring function. If the number we are going, if the place is equals to 0, which are when they are first created, and if they are equal to 0, it means that they haven't changed yet, which is the same as this being minus here. It's the same principle. If it's 0, it hasn't changed yet, we straight up place it. If the number is filled, we can't just say don't do it and go to the next number or select something else in the way we did it in HTML. We gotta say what the computer should do. So I checked if the current number is bigger than the number we are going to place. If it is, then place it to the next. If the next one is overflow, then we have lost the game. If the next one is smaller than ours, then we need to place it between, which is impossible, then we lost the game. Else, place. Same goes for the smaller one here. It's the same code, but with -1, bigger, etc. Checkboard goes through every number we have placed, if they are not 0, of course, and checks if they are positioned smaller to bigger. And if we have 20 full numbers that are positioned smaller to bigger, then we have won the game. We have won and lost functions which don't do much. They the lost one makes this integer go 1 up, won one makes this integer go 1 up. They both reset the game, which means resetting all of the numbers to 0, which we didn't have in HTML because you can just refresh the page. Also makes a game count ++, because I used to make the computer count in which round it is. I don't do that anymore, but the integer is still here if you guys wanna do it. It also writes it to console. So now I'm gonna do something. I'm gonna change all of the write to console to comment. And I am gonna only make these work, which are triggered when the 10 million games are played. What this will do is, this will make computer only record how many times it has won and lost, which will stop making 15 gigabytes of text files in the end. But we will not have all of the recorded games. So now I'm going to leave my computer. Wait a second. To play 1 billion games, so that we know a better percentage about the win rate. So see you in a bit. Alright everyone, this test is just ended. By the way, I changed few things. I made these into long because This was way too big for them. This was way too big for integer. Therefore, this will never be positive. So I made these long. And also this is wrong. This overflows, but it doesn't matter for now. Anyways, we have made our computer play this game 10 billion times. And now I'm going to check the results. I don't know the results, by the way. Let's go to the folder that this code runs. Let's open this with Notepad actually, because we didn't record the rounds, just recorded the result. And here we are. First, let us calculate. Well, actually, here we have 1.4, 0.0014%. Let's make it calculate this again. $10 billion. Okay. And 1. Actually, I was almost gonna forget that. So yeah, our first conclusion was very close to this. It is 0.00138 instead of 139999. So yeah, it is quite impossible. Thanks for watching my video, and see you on the next one.